In this video, we'll be making the crankshaft assembly of the inline four-cylinder engine. This is the final outcome. Uh, it contains the crankshaft and it is joined with the flywheel assembly. So we will do this in two parts. Let's first build the crankshaft. So this is where we left off in the last video. So let's create a new part under this project. Let's call that crankshaft, no, CS1. So this is going, we had four cylinders, four pistons, right? So each of the assembly should have different linkages. So we will make one linkage and we'll duplicate and mirror that to create three more. So we'll create a new body and a sketch in the XZ plane. So we'll start by creating the bigger circle of the crankshaft. So we will put 110 millimeters for this one and create another circle of 58 millimeters of diameter. And we will constrain these two to have a distance of 80 millimeters between the centers of the circle. Now we need to join these two circles using lines. So choose the line tool, select some arbitrary point on the circle and the same on the other one as well. Okay, so as you can see, the circle and the line are already constrained using this one. This is the coincident constraint. So we can change that to some other point if we want to. Let's duplicate that on the other side as well using the shortcut ZS to mirror it on the y-axis. Now, not only do we need to copy this, but we also need to put the constraints as well. So select the circle and this point, and now press on this button. This is the coincident constraint. See, we get the same thing over here, and we need to do this for this line as well. Now this line, this point. Now we can remove all these unwanted things inside the sketch. Use this trim edge tool and press on the areas we want to remove. So you might see this red line. Don't worry about that. That is just the radius constraint. Now we can close that and press on this pad feature. We will put 24 millimeters for the pad dimension. We will choose symmetric. See where we are going, right? Now we need to have an extrusion here, 1 hour here on the other side, and we will kind of mirror this to create other parts. Now we'll create a sketch on this side. Let's create a new datum plane here on this face and create a sketch for that. Now we are going to make this bigger circle, that is the center of rotation for this crankshaft. So that will be 40 millimeters above the circle. Let's create that one. It's going to have a radius of 63 millimeters and it will be constrained by 40 millimeters from the bottom. So let's choose the dimension. This point to this point, it will be 40 millimeters. All right, so let's close that one. And it will have a pad of 34 millimeters. Now we need another extrusion in this side. So let's create that one. Make a new datum plane on this face. Let's create a new sketch on that one. The circle will have a radius of 53 millimeters, smaller than the inner circle, and it will be 80 millimeters above the main circle. Let's close this one and choose the pad feature, and it will be padded by 26 millimeters. Okay, so this is the basic structure for the crankshaft. Let's hide the datum planes. We don't need to show that. Now this is the basic structure. So we will mirror this by this plane. So choose the body and click on this one. And in the plane, click on select reference and we will choose this plane. See, the structure for one piston has been created. So let's close this one. So this body will have all of this fusioned together as a single part. If you see a typical crankshaft layout, the first one is upwards, the second one is like, it's inverted. So we need to rotate the second body by 180 degrees. We could use the mirror tool, but it is much easier to clone it and then fuse it together using the Boolean operations. So we will be doing that one. So choose the body and press on this clone tool. It will create a new body. Let's put that inside this CS part. Okay. Um, Now we will use the transform tool to move it. Make sure that these are touching each other. Okay, so that's perfect. Now we need to rotate this by 180 degrees. We need to translate this up as well, because we set the origin to here. We need to be using this one as the origin. We can change that later in the assembly section. Let's work like this for now. Okay, so it has been properly aligned. Let's close this one. So if you choose the CS body, it will be like this. We need to fuse these two together. Uh, Before fusing them together, we can create the other two crankshaft parts as well for the other two pistons. So we will use this cloned body and we will clone that again. Put it inside the crankshaft part, transform it. Okay, and this part again as well. The body, original body, we will clone that again and we will transform that. Okay, so the crankshaft body has been created. Now we will join all this together. So let's choose all of this and use this Boolean tool. We'll do that in the part workbench. This one, union. So now we will see a fusion created here. So this is one body, all of them connected together. You cannot see no connection here because it's just one part. So if you try to move this one, it will move together. See, so the crankshaft has been created. Um, Next, the next work we have to do is to create the flywheel. For time being, we'll rename this part to CSA to signify that it is a crankshaft assembly containing the flywheel as well. All right, so Let's hide this one. This is the crankshaft, okay? Alright, so let's hide this one and create a new body inside this. Go to part design, new body. Now we will create a new sketch in the XZ plane. Alright, this flywheel is going to have many concentric circles for the different linkages. So we will start with the basic, uh, the base of the flywheel. This is the center. The first circle will have a radius of 63 millimeters. So that is the radius of the crankshaft, the shaft of the crankshaft, the main load bearing stuff. We will create another circle. It will have a radius of 74 millimeters. All right. Now let's close that and we will pad it by symmetric axis 34 millimeters. Okay. Now we will create a new sketch again in the XZ plane. Create a new circle with this as center 74 millimeters again. Another circle of radius 200 millimeters. So this will contain the inertial components like the holes that we will create in the next step. We will close this one and we will pad it by 20 millimeters symmetric. Close that one. Now create another sketch again in the XZ plane. Inner circle of radius 200 and then outer circle will have radius of 240 millimeters. We will close this one. Now we will pad it symmetric by 34 millimeters. Now we need the inner shaft. So let's create that one. Create a new sketch. XSL plane. Choose a center. Put 63 millimeters. Close this one. Pad it by 68 millimeters symmetric. Now we need an output shaft. Select this one first and then click on this. Press OK and we will create a new sketch. Choose the circle tool and set the radius to 45 millimeters. Close this one and click on pad by 34 millimeters. Press OK. And the next step is to create the polar pattern. So that is going to be the cavity is created inside the inside this part. So for that we need to create a datum plane. Choose this one. Press on create datum plane and press on new sketch. We will create a base circle. Choose this line and put the radius to 23.75 millimeters. And it will be constrained to the base x-axis. By 68 millimeters. So let's close this one and we will use the pocket feature. Create a hole As you see, the hole has been created. Let's close this, and now we need to create a polar pattern. So we will choose this pocket and press on this one and put the number of occurrences to how much you want. So I'm going to put 8 here, and the holes have been created. So this is the structure for the flywheel. You rename this to flywheel. All right, so now we need to join these two together. Let's choose this one and go to part workbench, and press on this union tool. It will unify these two. uh, Actually we need to transform this first. That was a mistake. Press on flywheel, transform. As you can see, the transform has been done correctly. Now we will uh, fuse this. Select this one and this one and press on union. See, the connection has been made strong, like we don't see the seam together, right? So the crankshaft has been created. In the next video we will be making the connecting rod and the connection pins and the connection screws and the piston pins.